Hello, everyone. So, today we are going to solve a problem from AMC 8, 2017, in fact. And it actually involves several interesting concepts. The problem says that Mrs. Sanders has three grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All three called her on December 31, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? So, this problem is kind of periodic. That's the first thing that I noted about this problem. So, on December 31st, let's call that day zero, all three children called. Then day one, day two, day three, until day 60. Clearly, on day 60, all three children call as well. Okay, because um, the first one calls on days that are multiples of 4. The second one calls on days which are multiples of 5. And the third one calls on, first one calls on multiples of 3. The second one calls on multiples of 4. And the third one calls on multiples of 5. So they all call together on days which are multiples of all three. So LCM of 3, 4, and 5, that's 60. So they all call on days 60, 120, then 180, 240, 300, and 360. So the problem kind of has a periodicity. So 61, 62, 63 till 120, 121, 122, 123 till 180, and so on. So these intervals are all similar. The patterns repeat. Why? Because if the first, see, the first son, the first child, calls on 363, 123, and so on. So for all days on the third column, the first child calls. So it's column wise. So columns are reproduced. Next column is for the second child. Okay. So the point I'm trying to make is that if we solve the problem for the first column, then we just reproduce it for the all the other columns. And of course, there are some extra days that we have to take into account as well. 361, 362, 363, 364, and 365. So we will consider those days separately. Okay. Now, so let's focus our attention in the interval 1, 2, 3, 4, 60. How many multiples of 2 are there in this interval? In fact, we don't need multiples of 2 because every third day, every fourth day, and every fifth day. So multiples of 3. How many multiples of 3 are there? So there are 3, 3 into 2, 3 into 3, up till 3 into 20. How many multiples of 4 are there? 4. 4 into 2, 4 into 3, up till 4 into 15. And uh, multiples of 5, 5, 5 into 2, 5 into 3, 5 into 12. So, and of course, these are the days where at least one of the children visits, right? So, if we take the number blindly, then there will be some 20 plus 15 plus 12. How many? How much is that? 7. 47 days on which at least one child visits. But there is a problem here. We have overcounted because among the multiples of 3, there are multiples of 4 and 5 as well. Among the multiples of 4, there are multiples of 3 and 5 as well. Okay? So we'll have to account for that overcounting. So I will write all that again. So we will subtract the numbers that occur twice. Which numbers are they? They are multiples of 12, multiples of 20, and multiples of 15, right? So how many multiples of 12 are there? There are 12, 12 times 2, 12 times 3, till 12 times 5, 15, 15 times 2, 15 times 3, 15 times 4, and 20, 20 times 2, 20 times 3. Now, how many numbers are there? 5. Here there are 4. Here there are 3. 12. Okay. Now we have to subtract these numbers because these are the numbers that have been counted twice. So 47 minus 12, how much is that? 35. Still there's a problem. Now there is some undercounting. Why? Because the number 60, which is divisible by all three, it has been subtracted too many times. We have to add that back in. Okay. So we have to do plus 1 because 60 was first counted thrice here. Then it was subtracted thrice. And then we'll have to add it back in. So plus 1. So 36. So there are 36 days in this cycle on which at least one child visits. So there are 60 minus 36 days, 24 days when no child visits. This is just the first cycle. Then from 61 to 120, there are another 24. For the next one, another 24. There are 6 cycles. So 24 times 6, 144 days where nobody visits. And we actually have some days left, which are 361, 362, 363, 64, 365. Now these three, so this is divisible by 3, this is divisible by 4, this is divisible by 5. So there are visitors on these days. On these 2 days, there are no visitors. Okay, so we have to add these two to the total count. 144 plus 2, that's 146. And this is the final answer. So, to recapitulate, the idea behind this problem was to note that this problem has a cyclic nature. Okay, so each 60 days, the pattern repeats. So we focused our attention to the first 60 days. It became a much easier problem. We solved it for the first 60 days and then we extrapolated. Okay, so we are done for today. If you like our content, please like, share, and subscribe. Uh, Tell your friends. And until next time, bye bye.